Good morning, students. Today we are going to discuss a case study on timetable scheduling problem using graph coloring. So, graph coloring is a vast area that can be developed using. It can be used to solve different kind of problems with the help of an algorithmic strategies called the backtracking. So, problem solving using graph coloring. So today we are going to discuss on timetable. What is the timetable problem statement, how to construct a graph for this real world problem, what is graph coloring, and how to coloring can solve this real world problem, and it is it NP hard or not. Okay. So what is a timetable problem? So normally we plan a timetable. We can timetable in a manual manner. We can using a pencil and eraser. We can erase it, and we can schedule the schedule with the faculties with a lot of confusions. To overcome that, we want to make it as a systematic manner. So systematic manner, we need some algorithm to construct a timetable. There are different kind of algorithms are there. There is a graph coloring, tape users, genetic algorithm, some optimization problems are available. So to overcome the difficulty in a manual timetable fixing, we move to the automatic systematic manner with the help of some algorithms. So problem statement. So initially the problem is no two faculties choose the same courses. Okay. So no same courses can be taken by any teacher or a batch for a given time slot. Then minimize the number of time slots. Okay, this is the two major problem today we are going to discuss. This is our today's case. How to construct a graph for real world problem. So normally graph is nothing but a collection of vertices and edges. Okay. So here we, for example, we choose five courses. There is an operating system, physics, calculus, electronics, and microprocessor. Each it should be colored with the different colors. The vertices represent the courses, as edges represent the conflict between the courses, and color represents the period in which the particular course is to be scheduled. Okay. What is a graph coloring? So graph coloring is nothing but a vertex coloring, edge coloring, or chromatic number. Vertex coloring is nothing but it's a way of coloring vertices of a graph such that no two adjacent vertices give the same color. This is a constraints for preparing a graph coloring. We want to color no two adjacent vertices have the same color. An edge coloring of G is a mapping of f is equal to G of G implies S, the element S or the colors and edges have a different. Chromatic number is minimum using a least number of colors we can color the graph based upon the number of vertices. So here consider there are n number of teachers with n number of subjects. How to map the subjects with the teachers? Okay. So the statement is, let us consider an example. In a college there are m professors. See, there are m professors, and m professors will be represented x1, x2, x3 up to xn. Then subjects will be represented y1, y2, y3 up to yn. Okay. Given professor xi is required to teach subject ya. So xi represent to for example x1 is ready to teach science, means x2 will not choose the subject science. Okay. Here the Pij is the periods. So construct a biparity multi-stage graph for the given solution. So in that way you can solve the real world problem. Okay. Initially consider single period timetable for a single period corresponds to matching a graph, and conversely each matching corresponds to possible assignment of professors. So see this graph here, x1, x2, 5, x4. There are here four professors and 5 subjects can be taught. The graph representation shows this situation. So this is the biparity multi-stage graph used to developing a timetable problem using graph coloring. Here the edges can be, the vertices can be colored with some chromatic colors. So the matrix representation of this will be shown here. So the conclusion is the timetable problem solving has many variations due to various constraints that can be tied to it. That is why we have considered as a NP complete problem. We can solve it. It's not belong to NP hard, because which problem have a solution that will be come under the NP complete problem. Okay. So you can does not have any polynomial time bound. However, approximate algorithm and heuristics such can be taken to attain the solution in a feasible time bound. So we can complete the timetable scheduling problem using graph coloring without any confusions. So this is the solution for the we chosen case study. So thank you for listening.